The tools used for explanation and prediction are known by many names, including theories, laws, rules, formulas, functions, algorithms, and etc. These tools, which I will call relators, tend to vary in appearance, but serve the same purpose: to show certain types of relationships between a certain set of objects. For example, the periodic table shows the electronic relationships between different elements. Newton's law of universal gravitation shows the gravitational relationships between different mass systems. The Mohs hardness scale shows the strength relationships between different minerals. And a computer vision model shows the visual relationships between different images. While relators allow us to study our surroundings, relators themselves remain rather difficult to study, as no notation yet exists that clearly displays the essential components of relators. In this video, I would like to share the concept of a relator diagram, which I believe enables the effective study of relators. To introduce relator diagrams, I will begin with the computer vision model brought up earlier. The model's relator diagram is pictured below. Each number here represents a different object. If two objects fall into the same set, they are considered to be equivalent. Otherwise, they are considered to be unequivalent. Notice how the relator diagram clearly displays the relationship of the objects. To develop this relator diagram from scratch, it may be helpful to begin by labeling the sets more descriptively, as done here. It is important to realize, however, that descriptive set labels communicate the same amount of information as non-descriptive set labels. Relator diagrams grow more complex for different relators. Here I have included the relator diagram for a simplified version of the Mohs hardness scale, which considers only 4 outputs and 4 objects. Unlike before, objects are grouped in pairs. If 2 pairs fall into the same set, their relationships are considered equal. For example, the pairs talc and calcite and talc and fluorite share the same relationships. By using equivalence relationships to talk about relationships, the relator diagram can represent the simplified Mohs hardness scale. One interesting point to note is that multiple relator diagrams can represent the same relator. For example, this simplified classification network is represented below using 2 different relator diagrams. I will now move on to an even more complex relator, which involves the number line. The simplified law of universal gravitation actually shows 2 different relationships between objects. Object B is not only 2 units less than object C, but also 1/2 of object C. To create the relator diagram, it is first necessary to create some placeholder objects. This will enable the representation of quantity using only equivalence relationships. Because the simplified law of universal gravitation displays 2 different relationships, 2 separate relator diagrams are necessary for its representation. These 2 relator diagrams clearly display the immense amount of information that is compressed into the number line. I believe that every relator can be represented by its own relator diagram, although I have not formally proved this conjecture. If this statement does happen to be true, I believe that the generality of the relator diagram will enable it to be applicable to many existing and future fields. Thank you for watching.